musical sound, we're interested in these periodic, repetitive waves. So it seems fair to ask at this point, what does the frequency, that is the number of sloshes per second, have to do with the sound that we hear? Okay, and to understand that, it's probably best to just try it. I'll play you some sounds, and what I want you to do is listen to the sound, think about the pitch of the sound, and also watch the wave here. Okay, this is time along the bottom, so if the waves are squished up together, that means they're high frequency, they're coming often, and if the waves are stretched out apart, that means they're low frequency, they're coming less often to the microphone. All right, so let's make this sound. So we'll start again at low frequency. So that's a 140 hertz tone. You can see that the waves are nicely spread out. And now I'm going to increase the frequency, which means increasing the number of waves coming by each second. Now we're up to 600 hertz. You can see the waves are much more closely spaced together on the screen. So that's a higher frequency, more waves per time. And you'll also notice a higher note. I'll keep going a little bit. So there's 1200 hertz. You can see the higher frequency represented by the waves that are more closely spaced together. And again, we've gotten up to a much higher pitch. So what you'll notice is that as I turn down the frequency, the waves stretch out here and the note goes down. So the way we describe the pitch of the note is high for high frequency, low for low frequency. Okay, so we've definitely figured something out here, right? We've figured out that the frequency of the sound wave, the number of times it shakes per second, is what determines our perception of the pitch. So high pitch is high frequency. Okay, so we can do more than that with pitch. We can also think about how the frequency corresponds to the way that we commonly describe pitches. So musically, one of the most frequent intervals we talk about is the octave, right? So here's an octave. Right? And a musical octave corresponds to a doubling of the frequency. So if I start with 200 hertz and then I play 400 hertz, you'll hear those an octave apart. Or 800 and 1600, those are an octave apart. This shows you here the ranges of frequency for a lot of common instruments. So this goes down here from 10 hertz, which is just below what we can hear, up to 10,000 hertz. Remember, we can hear up to 20,000. You'll notice that the musical range that we use to play music actually consumes a good fraction of what we're possibly able to perceive. So we can hear from 20 hertz to 20,000 hertz, and we use, even just with the piano, most of that range. The piano goes from 27 hertz up to about 4,000 for the top note. Okay, the human voice, this includes sopranos, altos, tenors, basses, you name it. The human voice kind of runs from 100 about up to 1,000. Here's the tuba that my son plays, and the piccolo that no one in my household has attempted. Okay, so that gives you kind of a sense of the range that we have. Okay, and this is to show you again how frequency of the sound wave corresponds to the pitch that we hear. This is a low C on the piano, 262 hertz. Here's the octave above at 524, and you can see that's doubling like it should be. Okay, another common interval that we're used to musically is the musical fifth. So say from C to G, right? And that actually is also a simple interval. Here's the C, 262. Here's the G, 392. If you stare at that for a moment, you'll see that that G is 1.5 times the frequency of the C. Okay, so if you take a frequency, you multiply it by 1.5, you get the note that's a musical fifth above. And if you multiply it by 2, you get the octave. Here, right here at 440, is the A that the orchestra tunes to, right? So you may have heard people say, oh, we want A440. right? 440 is describing the number of oscillations per second. So this is the A, the open A string on the violin. Okay, so we've said that, that how often the air is shaken by the instrument determines the frequency of the sound wave, and the frequency of the sound wave determines the pitch, the musical pitch that we hear. So it seems like the honest questions to ask at this point would be, what determines the frequency at which the instrument itself